Hello, in this video I will show you how to do a proper analysis in VieVS. Oftentimes there might be errors within a session. For example, it often happens that the clock jumps during the session, or maybe one station or a baseline is a little bit noisy and you want to remove it from the analysis. You can do this in VieVS with so-called opt files. Here I've selected a couple of sessions which all show some errors, and we will go through some of the sessions in this video. In order to use opt files, you have to check this down here. You can now right-click on one session and say Open Create Opt File. This will open an editor where you can see the opt file for this particular session. The opt files are stored in the VieVS directory. If you look at the VieVS directory, then you see that there is a VLBI_opt folder. In this folder, there are several subdirectories, for example the default subdirectory. We have selected default here for our opt file. In the default directory, you see in folder 2019, since the session we were right-clicking was from the year 2019, and in there is exactly this opt file. You can see all the options that we have in VieVS. For example, you can add some clock breaks where clock jumps occurred. You can also exclude some stations from the analysis or exclude them partially. You can also exclude baselines or sources, and there are even more options. For now, we can close this opt file. Next, we will start the processing in VieVS. We will go to Run Options, define a subdirectory name. In our case, I call it opt test. Use parallel processing and click Save on Run. Now the processing is done and we can have a look at the results. We will have a look at the residuals first. So first, load the opt test folder, and now we see the residuals of the session. You will see that the main solution lists a chi-squared of 5.5, which is well above 1. In an ideal world, the chi-squared should be around 1, or let's say as low as possible. The residuals should usually be normally distributed up around 0. We can clearly see that this is not the case here, especially during this time. It's often easier to spot errors not in the main solution but in the first solution. The first solution is a least squares adjustment with a reduced number of estimated parameters. If we now filter the residuals per station, we can see that for Badari we have a lot of observations which look quite okay. They are all scattered around 0 and they look more or less normally distributed. But here we see that there are some outliers and also something like this here. Now let's have a look at the next station. Here, the station Matera. Matera has a weird drift in the residuals up to this point. Then the residuals jump down. Then they jump up again, and then they will have again a trend in the residuals here. So this is an example of a clock break. So here the clock was drifting, now we had a clock jump, couple of observations and another clock jump, and then the rest of the observations. So now we need to tell VieVS that there were these two clock jumps. First, zoom in a little bit. Now we can add some clock breaks at the time where the clock jumps occurred. You simply click on the Add Clock Break button and click somewhere in between the observations. Now we've added the first clock break and we will add a second one. Now we can rerun VLSM again and have a look at the new residuals with the additional clock breaks. What VieVS does is it will estimate one clock up to this point, then it will estimate another clock here, and then it will estimate another clock here. Now the processing is done, and we can have a look at the residuals, and they look now a lot better. The jump is gone, and if we zoom out again, we see that the observations look now a lot better. By the way, I was using this rerun VLSM button down here. This is a shortcut that you can use if you just have added some clock breaks or did something in the analysis to simply run VLSM again. This saves you a lot of time. If I switch back to the main solution, I can see that the chi-square is now 1.4, so it's a lot closer to 1. And if I have a look at the residuals, I see that they are now looking a lot better. They are looking more or less normally distributed, scattered around 0. Now we can have a look at the opt file to see what's going on in the background. If I open the opt file again, I can see that VieVS has simply added 2 clock breaks in there. So if you want to remove one clock break again, you can simply remove the line here from the opt file. Make sure that you also change the clock break counter at the top. Now we can again check if we see anything else looking weird in the residuals. We can filter by station, or maybe we can also filter by baseline. But for me, everything looks more or less okay. It all looks more or less normal, distributed around 0, and that's what we want. So I think it's a good idea to move on to the next session. Next, I want to process this one here. So I select it, and here again I see that the main solution looks not really good. So the chi-square is well above 200, and we see that especially here on the right, there are some very big outliers. Again, it might be easier to spot the error in the first solution. If I select the first solution, you can see that the residuals are looking very weird. Let's filter the residuals per station. Station Badari. This is Fort Laser, and Fort Laser, you can see that you have this drift here, this drift of the residuals, and then suddenly you have some residuals all the way up here, and this is again an example of a clock break. So what you can do is you can add a clock break for Fort Laser. Click somewhere in between the observation blocks to add the clock break, and then rerun VLSM. After adding the clock break, you can now see that the biggest residuals are gone. Let's zoom in a little bit. If we switch back to the main solution, you can see that the chi-square is now 1.6, so it's a lot closer to 1. I will go through all the residuals again in the first solution of every station to see if I see another clock break. You can see that, for example, the station Sejong is quite noisy. The observations, they don't really look normally distributed. So maybe it would be an idea trying to exclude the station Sejong from the session. But I will keep it in there for now. Let's have a look at the main solution. And again, you see in the main solution that Sejong is leading to the most residuals. So maybe it's worth trying to remove Sejong, but as I said, I will leave it in there to keep the observations. I think it's fair to move on to the next session. Next, let's have a look at this session. Here you can see that by default the chi-square is 1.4, so it looks already quite good. Let's have a look at the first solution again. The first solution for Aggo is quite noisy, so the observations are not really normally distributed around 0. Let's have a look at the other stations. This all looks more or less good. Warkworth is also looking a little bit weird, but there is not really a clear jump happening. So I leave it for now. And here it's Yarga D. In Yarga D, you can clearly see that the residuals are moving up a little bit. Then I guess here is a jump down. Then there is a little bit of a jump. Then there are again okay, but here is a third jump. So I guess that there are 3 clock breaks at the station Yarga D. Let's zoom in a little bit. First I will add a clock break here. Now I will add a new clock break in here. And let's also add the third clock break. It was here. And rerun VLSM. If we now look at the residuals of Yarga D, we can see that the jumps are mostly gone. So the jump is really gone. Let's have a look if this affected the station Warkworth as well. And you can see, yes, it's looking a little bit better, but you still hear a drift. But this drift, let's have a look if it is only also in the main solution. And in the main solution, you don't really see it. So I think it's fine. Let's have a look at the stations in the main solution. So Yarga D, they all look more or less normally distributed around 0, so all looks good. Fortaleza is a little bit noisy, but okay. Yeah, and unfortunately Argo is quite noisy. So again, you can maybe try to deselect Argo and remove him from the session. But nevertheless, since Argo is the first station in the VGUSDB file, or the first station alphabetically, it is also set as the reference clock station. During the least squares adjustment, you always need to define one clock as the reference clock. Usually, VieVS takes the first station. Since the first station is Argo and it's quite noisy, it might be a good idea to change it to another station which is more robust. For example, Wetzel is often a very good choice. So you can simply add Wetzel as a reference clock and click on Set. And this will change the reference clock in the opt file again. We can have a look at the opt file. So the session was the January 27 session. And see that here in this example, we have set the reference clock to be Wetzel and we have added 3 clock breaks for Yarga D. Let's redo the least squares adjustment. This time it didn't really change a lot. So as I said earlier, you can also try to maybe exclude Argo completely from the session. I can do this by adding Argo to the stations to be excluded in the opt file. Save it and rerun VLSM. You can see that Argo is now no longer listed in the session. But the chi-square didn't really change. It didn't really improve the session at all. So I would redo this and again add Argo to the session, save the opt file and rerun it again and keep Argo in there. You can further explore the session and see if you can see anything else that looks weirdly or that needs to be improved, but I will move on to the next session right now. Let's move on to the next example. Here I can again see that the residuals don't really look normally distributed. I again have very high residuals at this time here and also a little bit later here. Let's have a look at the first solution of the stations again. But if I go through all the stations, I don't really see any obvious jumps. And I see that the residuals, the big residuals, they're really in all the stations. So maybe this issue is not related to a station. Maybe it's related to a source. If I go to the sources and I go through all the sources, I will see that if I go to source 1224, this source is really leading to all the problems in the session. And to a lesser extent, it's also source 1229. So it might be that these are some new sources that are not that regularly observed, and therefore they have bad a priori coordinates. So what I can do now is I can try to remove the sources from the session as well. But keep in mind, if you really remove the sources, then they are gone from the session. So there's no way to estimate better coordinates maybe during a global solution or when you estimate a celestial reference frame. So it really depends if you want to remove sources or remove stations from the session or not. It really depends on what you want to achieve with your session. In this tutorial, let's have a look how to exclude sources from a session. So first, we need to tell VieVS in the opt files that we want to exclude this source. But if I go to the VLBI opt default 2020 folder, I can see that there is no opt file for this session yet. So what I have to do is I have to go to File, Set Input File, and create an opt file for this session. In this opt file, I can say that I want to remove one source, namely source 1224 plus 141. I can save this opt file, go back to plotting residuals and run VLSM again, and see if this helped or not. Usually, if you estimate source coordinates, wrong a priori coordinates should not really lead to a problem, but it seems that here it was. Maybe there are other problems like the datum definition or the a prioris, but we will explore this in one of the upcoming videos. For now, for this tutorial, I simply want to go through the opt files and see if we can solve the session. So now we have removed this source. It's not listed in the session anymore. And if I go to the main solution, I can see that the chi-square is now 1.4. And if I go through all the residuals, I can see that the residuals now more or less look quite okay. Okay, if I'm happy with 1.4, I can move on to the next session. Next, have a look at this session here. Again, the chi-square by default is 1.4, which is quite okay. If I look at the first solution and filter by station, I can have a look at the residuals again and see if there are some obvious jumps. So far all looks good, but here Yarga D we again see some obvious jumps. So we have to add new clock breaks for Yarga D. Let's zoom in a little bit and add the first clock break. Simply click somewhere here. And now let's move on to the second part of the session. Okay, here we can again see that there is obviously a jump happening here, but it's not that easy to spot where exactly it was. So I guess here this should be all related to the same clock. Here is just a little gap in the observations, and I guess that here the jump happened. So I will add a new clock break in here. I can close the folder here again because we don't need it anymore, and I can again click on rerun VLSM to see if this really solved the issue and the result looks better now. During this tutorial I've shown you a lot of things that might show up in the analysis of VLBI sessions, like clock breaks or stations that are noisy or so. But for the sake of the tutorial, I went through the sessions very, very quickly. So in reality, maybe it would be a good idea to keep a little bit more time and explore the session more in detail. Maybe also look at the baselines, if there are some baselines that need to be excluded or so. But for now, let's have a look at the session again because the processing was done. If I zoom out a little bit again, I can see that YARIGAD is now looking a lot smoother. So it's now all the jumps are gone. And if I look at all the stations, I can see that there are not really obvious jumps happening. And if I move back to the main solution, I can see that the chi-square is now 1.2, which is closer to 1. And I think I can be happy with this session. So I think that was everything I want to show you in this tutorial. This was just a tutorial to give you some insight in VLBI analysis and all the issues that can arise. There is a lot more that we will cover in the next videos. And in reality, as I mentioned, maybe you should take a little bit more time and explore the sessions more in detail. But that's everything from now.